In this video, we're going to consider kind of introducing the concept of differentiating integrals using the Leibniz rule. If you can find the videos by going to the website and then click where it says free calculus videos, and then once you get to that section, scroll down to where it says differentiation of integrals. And again, this is the Leibniz rule technique. And the idea behind it is pretty basic. Suppose we have just some general integral, say f of x dx. When we integrate that, this will give us a different function of x plus some arbitrary constant. For example, suppose we just had the integral of x squared dx. So that, of course, is 1/3 x cubed plus an arbitrary constant of integration. But here, for this problem then, small f of x is x squared, large f of x is 1/3 x cubed. But anyway, if we're taking the integral of some function f of x, it's going to give us a different function. We'll call it capital f of x. And integrals, they are antiderivatives, so we know that d dx of big F of x equals f of x. And again, we can see it just with our trivial example. The integral of x squared dx equals 1/3 x cubed. We can say plus a constant to be complete. But it's the derivative of this that returns this function. Now, suppose then that we have this integral and want to take the derivative of it. So we have d dx of this integral. Well, then that would be the same as taking d dx of big F of x. We could say f of x plus the constant, but that's just going to be 0. And this derivative, though, is just f of x. So if we have an integral, its derivative is, for this simple kind of a case, is just the function inside of the integral. Now suppose that we have an integral of f of x dx and we take the differentiation not outside of the integral, but we move it inside of it. So first we'll make more room. So we have d dx of f of x dx. Well, these cancel, so now we just have the integral of d f of x. But of course that's f of x. The derivative, or the integral of any, say, d theta, that's theta. Or the integral of dx, that's x. So what we see is that it's a simple system then, that d dx of an integral can be obtained by differentiating inside of the integral. And that, in a nutshell, is the Leibniz rule. That to differentiate, you take the differentiation inside of the integral. Now, where it gets more complicated is when we have more complicated integrals to deal with. We might have an integral of, say, some function f of xt dt, and we can have limits on the integral, and the limits might not even be constants. We might have it where we have a limit u, which is actually some function of x, and a limit v, which is some function of x. So we get to more complicated integral type situations. Those we will consider in the future videos. Right now, we just wanted to give a brief introduction to the concept of differentiating integrals, and in a simple way, the application of the Leibniz rule. Now, in the next video coming up, we'll consider more complicated integral type situations. And what we will see is that, also in the future videos, we can have complicated integrals that we don't know how to evaluate them, but we can take their derivatives. Then once we know the derivative of the integral, we can figure out a way to go back to the original integral and find a way to evaluate it that before we could not do. But those will be coming up in the future videos, so stand by for those. And remember, again, the playlist for all the videos is at the website digital-university.org.